I'm really excited if you all to hear this talk. I sat next to Jeff last night at the speaker dinner, and I'm really excited to hear a little bit more about what he teased related to the smart cities projects that he's working on. So give him a round of applause.
And for anybody who really knows me, I can really talk, but I promise I'm not going to fill up all the extra time. We'll give you some more of your lives back at some point later in the afternoon. I've been coding in Elixir for about 2.5 years now, and for the last little over a year now, been working on a project for the city of Columbus, hometown, to democratize big data. So we want to enable cities to start thinking of data more like a public utility. And we think that Elixir is going to be probably the most powerful tool to get us there. So what is a smart city? Well, for context, in our case, in 2016, the city of Columbus won a grant from the Federal Department of Transportation. It was the first annual Smart City Challenge. So the goal was to use emerging technology, things like connected sensors, connected vehicle infrastructure, to better manage transportation resources, to address social issues related to urban mobility in sort of this new modern landscape. We want to be able to address problems related to things like access to healthcare, access to food, education. And we want to do it in a way that creates sort of an open data hub. We want to make a place where everybody can come together to share data, to explore data, figure out ways to use it to address some of these problems, find problems. And then we want to make sure that this thing that we build is open source. It's a taxpayer-funded project, and we want to make sure that everybody can benefit from it. So we pave the way, and a rising tide lifts all ships. So the challenge, we have some caveats. It has to be cloud agnostic. Some people, your city might have a relationship with a particular cloud provider. You might have a beef with another. We want to make sure that just because we got a lot of money from Amazon to build on their platform as part of this pilot project, that everybody else, depending on whatever their situation may be, they can utilize the technology to the same benefit. It's got to be cheap to adopt and maintain, right? No licensing fees, free and open source software. It has to be efficient in the use of resources, cheap to run, and it has to be cheap to operate and maintain. We want to be able to allow a small team of not terribly skilled or expensive operators to maintain this on a day-to-day basis. Any city of any size, regardless of big or tiny, very rural, should be able to use the platform to improve their region and only really pay for as much data as they want to use. And we have to keep in mind that there is value that we provide to a wide variety of stakeholders. This is an urban region that we're sort of planning for, and so we've got different sectors. We want to be able to offer something for everybody, right? So government is the first obvious one. We want to certainly address the needs of local and regional government, but potentially bigger, right? Private enterprise, in particular, right? We want to target the startups, the small and medium businesses, and we want to empower them to be data-driven and data-informed. We want to enable them to level the playing field with large enterprises that have traditionally dominated this kind of problem solving because they can afford an army of data scientists. We want to empower researchers, right, to find and articulate problems that we haven't even discovered yet, particularly around where data has been disconnected, disparate, right? And they don't see a problem until they're able to bring those two or more data sources together and start to correlate, cause and effect. And even enthusiasts, individual hobbyists. In Columbus, for instance, we have a group called the Open Data Enthusiasts. They are actively, on their own time, using the platform and its data to provide web applications that solve problems in the community. So they are building they've built one application for finding social services. They have another one that they're embarking on to map the sidewalks, make sure that we know where people can go safely, regardless of their mobility. So let's get started. Our foundation, right? It's got to be cloud agnostic. and we need it to efficiently use its compute resources, right? Well, we turn to Kubernetes for that. Kubernetes is the de facto standard today for cloud infrastructure abstraction. Every cloud provider, major one, and most of the minor ones support it and even provide managed solutions so that you can not worry about that particular component in your stack. You can just get to solving the business problems. We need to provide cheap, scalable storage, right? We're talking about a lot of data, and we don't want it to cost a lot to store all that data. So we're going to turn to cloud-based object storage for that, and all of the other providers have been kind enough to follow Amazon's example and code to circle their wagons around more or less a standard API that we can code against and we can trust to be there. And finally, we need it to be low maintenance, and that's where we think Elixir is going to come in and solve the rest of our problems. So you may be hearing this and thinking, if you have any familiar with it, this sounds like a problem for Hadoop, right? Not so fast, right? So traditional Hadoop, if you're familiar with it at all, right? It's notoriously expensive. The resources are not cheap, and it doesn't scale well. This was, this was a technology that was designed for the data center of the early 2000s, right? You know how many server racks you have, and you're not going to be able to grow beyond that without a lot of planning and a lot of money, ahead of time. This is not the era of virtual infrastructure with a credit card. Because it doesn't scale, it's not truly cloud native. So we can't make that solution as affordable as we possibly can for those very smaller cities with lower budgets. And it's notoriously difficult to manage, maintain. If you've ever used it or any of its components, it's very difficult. You generally have to have a team of very highly trained and expensive people to make sure that it's running on a regular basis. But it's 2019. Somebody has to have put Hadoop on Kubernetes at this point, right? Well, we tried. For a while, actually, early on. It did not work out so well for us. We even spent some time talking with a third-party cloud and independent Hadoop distribution vendor. I will not name names to protect the innocent, but that's not the direction they're going in, right? Where they are targeting sort of dynamic scaling infrastructure and utilization of resources is in the cloud infrastructure space, that virtual infrastructure. But there are some bright spots, right, that are coming out of the, coming out of this ecosystem, in particular around how do we store this massive amount of data in the cloud at cost, right? And that comes from a project originally out of an early project. This one, again, this is sort of the second generation, both out of Facebook, where they allow you to lay data down in large quantities on object storage and flat files, and then query it like a SQL database. And so you get the interface that you want to respond to it quickly and do intelligent analysis on that data, but you can put it, you just blast it across S3, and that will grow until Amazon shuts down, or your credit card runs out. And you can use all of these numerous efficient storage formats to be able to query the data back. You can respond to it very, very quickly based on your response needs and the types of queries or the types of data that you want. So, it's come to this. We've decided that we have to build something new that nobody's seen before. We have to reinvent the wheel a little bit here, and then we have to sell it to our stakeholders. So the good news is we already had some Elixir on the edges of the system. We were doing some sort of early proof of concept work around streaming data and handling that. So they're familiar with it at a high level. This is not a technical audience, but they've worked with technical people long enough. They know some of the high-level details. So we just need to be able to articulate, hammer home, what does Elixir, what does OTP do well? How does it address the particular problems that we foresee with this project? So the first one is concurrency, right? That's one of the first things you think about when you think of Erlang and Elixir. It handles concurrency. And we envision, right, that there are theoretically, we hope, that there will be thousands of data sets flowing through the system at any given time. And they could be coming from lots of different providers, lots of stakeholders. We want to make sure that negative performance on any given one, any bottlenecks, don't impact the performance of any of the others. We're going to be doing a lot of data manipulation, right? And because Elixir is a functional language, because of its capabilities in binary pattern matching, and again, because of the, this massive standard library that we get from 20 plus years of Erlang and from the Elixir core team, and then the massive extended library provided by the community, you all, this is going to be a really easy prospect for us. And resiliency, that's another thing that we think of, again, self-healing. We want this thing to be self-healing. We can embrace the patterns of OTP, of the actor model, and let it crash, and we can make sure that we build self-healing into the system relatively easily so that we can employ a small team of relatively lower skilled technicians to operate on a day-to-day basis and troubleshoot as problems do eventually arise. So it's been several months, right? And we've now got this robust ELT ingestion pipeline running in production for the City of Columbus as we build out this general platform. It's written entirely in Elixir, with the exception of, again, that database engine. We are doing periodic ingestion of static data sets, so one-offs or batches that run on a cadence. We will ingest them and persist them to that object store, but we're also taking in streaming data from a couple of different sources, and we treat streaming data and technically I'd say we treat streaming data as the first-class citizen, but we handle both the same way. We make sure that there is one path through the system regardless of how frequently you're sending data in. We stream that in, we persist that as well in perpetuity, however long we want to keep it, that we think that there might be value in being able to refer back to it. But we also stream it right back out the other end via WebSockets that we manage with Phoenix, so that you could theoretically hang applications off of that data. It might be the raw data, there might be a consumer that has value in that raw data, but we can also do transformations on it on its way through the system, combine it with other data sets or other insights before we send it back out, whatever is valuable to the consumer. Right, we've got Phoenix apps on both ends, Phoenix APIs for management, data curation, and administration on one end, and then on the user end, right, for discovery and analysis of the data, powering the React front end web UI that we built. We make liberal use of pattern matching throughout the system, so we're parsing data, we're matching it against a schema that we define on a given data set. When we first define it in the system, we try to cast it and then route it through the system accordingly based on its response to that schema. We do optional caching, right? So that particularly with streaming data sets and issues related to the frequency of the requests that we do that ingestion, we want to make sure that there's no duplication that's erroneous. If there is statistically significant information there that would be impacted by duplication, we want to scrub that out and make sure that's available to be handled. And we want to do batch upload, particularly because we don't have Elixir in our database engine that's interfacing with this S3 interface. So we want to use that resource efficiently and make sure that we aren't overloading it. We're back pressuring, we're not bottlenecking. But you will notice that I said ELT, not the traditional ETL that you may be familiar with if you've done data processing. So because we don't have a single well-defined stakeholder, we don't have a single well-defined collection of data, the transformations that you might want to do are entirely up to your imagination based on what you discover, right? This is an ongoing process. You can continue to churn and enrich that data however you see fit. So we can deploy into this Kubernetes environment additional microservices that we build entirely in Elixir. That's our wheelhouse. That's where we're most comfortable. That's what we would choose. But we also, again, want to be open and accessible to other teams that may not have Elixir developers on staff. And I'm sure any one of us would welcome them contacting us, but maybe they need to get moving fast in the stack that they're comfortable with, so we can then turn to Elixir as the orchestrator, as the supervisor, sort of the way Justin was alluding to earlier this morning with nerves and the non-Elixir runtimes. We can do the same thing with other components in this ecosystem that we manage with Elixir, and we can even further extend it with other languages and frameworks that do, say, like specialize in real-time or micro-batch processing. So how do we support this composability, right? We're going to make some trade-offs here. There we go. So we could get a lot of good performance out of directly sending Erlang terms encoded over the wire between components, but we want to be flexible with the potential for non-Elixir, non-Erlang applications. So we're going to loosely couple everything with Kafka. We want Kafka specifically because of the performance. Kafka, a well-tuned Kafka cluster, I believe, can theoretically reach 100,000 messages a second on a given topic, depending on how you do it. And we envision the need for that in certain circumstances, certainly related to IoT streaming, sensor data, connected vehicle environment data, things like that. And we're going to use JSON as the universal language that all of these applications talk to each other in, right? It's ubiquitous. Everybody speaks JSON. And so it's not going to be a stretch for any other player to come into this space and be able to speak the same language. But the problem we find with Kafka in Elixir, right, is that there's no clear winner in a client to interface with Kafka. The obvious front runner would be Broad, but Broad's got a very difficult API. It's very terse documentation, and personally, I think that they're assuming a very static definition of a Kafka cluster, a very well-defined set of topics, and we need something much more dynamic, something that we can sort of create and destroy things at will. And so we built Elsa. Right? So Elsa is a reference to Broad, Max Broad being Franz Kafka's friend and publicist, Elsa being Max Broad's wife. We have a team member who likes to say let it go every time we bring it up. We ignore him now. Elsa's built on top of Broad because while Broad's API is not the best for our use case, there's a lot of good prior art there that Klarna's built in, especially in particular to the Kafka protocol, that lower level protocol that they built Broad on top of. But we add usability and very dynamic orchestration to that functionality, very unopinionated supervision strategy. But at the end of the day, Elsa is just another very, very good Kafka client, and we need to be able to performantly manage this interaction with Kafka to a higher degree, and so that's where we turned to Broadway. Now, we reached out to Plataforma Tech, we were put in touch with them, and they are interested in extending Broadway to the Kafka ecosystem. They've been working on it. We happen to have a lot of, unfortunately, experience working with Kafka, so we were very familiar with it, with the problems that arise, how to interact with it, and so we needed something fast, so we built it ourselves. We used Elsa as the base, so as that interface to Kafka. You can actually thank us for the off-Broadway naming convention. Anything that's not officially supported by Plataforma Tech, we encourage everyone to use that now. I believe they do too as well. Because we have Broadway in our stack, we've had it now for a couple months, we get all of those massive benefits of concurrency and back pressure. And Broadway has some strong opinions about safely handling messages, not erroneously duplicating or dropping messages, being able to drain a consumer safely when things are coming down, and we want to be able to take advantage of that and make sure that the system is as safe in the handling of all those messages as possible, because they could all be very, very important to you and your use case, your applications. And then sort of unrelated to that, we have a distributed services running in Kubernetes, right? These are all microservices. They need to talk to each other. They need to interact in the same space. And so we turn to an event stream, the event bus idea. And my colleague, Brian Balser, who is in the room here, he was the brainchild for Brook, named after the event stream. So it provides two high-level capabilities. It's got an abstraction layer over a message log. In our case, we're using Kafka, but theoretically, it could be anything else, right? So it generate messages, share them. It sort of follows a Broadway model in terms of its API there. Sending messages out into a shared event stream. You match on the patterns that are relevant to you as a particular component in this shared ecosystem and do things. But it also has an abstraction layer over a persistent view, right? It's going to, any component that implements Brook is going to act on that event, and then it has the potential to store whatever is relevant to it, some piece of data about that event in its own personal little memory space, and maintain a system view that's lightweight and only relevant to that application. So we'll take a quick walk through the journey of a data set through the system. It's our most recent diagram, architecturally speaking. So we start out over here at the management API, where we post a declarative data set definition in JSON, and it blasts a message out onto the event stream. Get ready, wake up, do stuff. Create your Kafka topics, create your consumers and your producers. You're going to have work to do in a minute. So over here at 2, we gather data at the edge, right? It's either pushed into the system or we pull it. We parse it, from basic parsing, and then we parallelize it on Kafka topics. So we get all of that concurrency there. Every topic gets every data set gets its own topic, so there's no negative impact one over the other if anything goes wrong with any one data set, and it continues on that way through the rest of its journey through the system. Over here at step 3, we're going to normalize. We're going to validate that data against the data set definition, the schema that came in with that. If a particular message doesn't immediately conform to that schema, we try to coerce it and cast the types and the fields to the various things that we were expecting. If and only if we can't, right, we're going to dead letter that message, and we'll come back to it later if we're able to. Step 4, right, that's where we're going to persist the data into the persistent store, but at the same time, right, if it's a streaming data set, we're going to stream it right back out the other end for someone to consume off of. And because it's more or less done with its journey through the system, at that point, we're going to blast another message out. We've probably been doing this throughout the system at some point. Eventually, we can build APIs into the user interface, into the management interface to say, this is where this particular data set is on its journey through the system. You're 90% complete with this batch, for instance. But we're going to blast a message out in the event stream now to reclaim those resources, tear down your consumers, reclaim those processes, revoke those Kafka topics. There's theoretical limits to the number of topics and partitions that Kafka can handle, and if we want to get to the scale that we're talking about, we need to make sure that we have considered that early on. Step 5, right, we've also been assigning metadata to messages as they traverse the system, right, timing related to some of these operations and things like that. We're going to analyze that in another application on the back end. We're going to sort of parse it, recombine it, and then store it again in its own internal system table for later analysis, for debugging, things like that. And then, step 6, 7, 8, 9, et cetera, right? This is an example of one of those value-add transformations. This one in particular is listening on the event stream. It's responding to the ingestion of a particular geospatial file format called a shapefile, and it's converting that into a more flexible GeoJSON format and then re-ingesting that into the system. So who's using this thing? Right? We've got a number of people at the very front end in Columbus. We're all co-located on the same sort of flagship deployment and living that model of the Open Data Hub. This is what we call our production system every day. So the first one was our local bus company. They have a GTFS feed that sends us near real-time data on the positions of their buses throughout the city, and we use that to stream it in. We persist it. Somebody can do analysis in it if they need to at a later date, but we also stream it back out, and then we have a web application on the front end that provides a near real-time, it's updated every 10 seconds from the bus company, map that shows exactly where your bus is, and you can filter by the route and see where you are on the map. Where the heck is my bus? Why isn't it here yet? I expected it 10 minutes ago. There is a project within the broader Smart Columbus grant being conducted by The Ohio State University into prenatal trip assistance. Basically, they want to validate after the terms of the study is done that access to healthcare, particularly in at-risk and marginalized communities, lowers mother and infant mortality. We've got the Department of Infrastructure Management for the City of Columbus. They're going to do an efficiency project with us here shortly. They're going to start feeding in their work order database and then use that. We're going to build them a web application that provides in real time to them, updated from their technicians in the field, what's going on so that they can allocate resources efficiently, particularly in some of those high-stress seasons like snow clearing season in the winter, pothole filling season in the springtime. Why isn't the side of the road mowed? Well, we had a terrible winter, and so we spent 3 extra weeks filling potholes. We got the Mid-Ohio Food Bank, which is a very, very large collective of food assistance within Central Ohio. They're going to start feeding in their real-time food resource availability into the system and use that to provide information to their potential, service population, where to go within their network of food pantries, soup kitchens, and partners to find the food that they need. And then we've got a number of different research organizations looking into an upcoming project, again, part of that broader Smart Columbus grant research, where they're installing connected vehicle infrastructure along a particularly busy corridor within Columbus. We're going to stream all of that data in. This is very, very interesting to these researchers because typically they've been limited to the amount of data that can be stored on any one roadside unit, and usually about 1.5 gigs of data after a day. And we're going to be able to give them the volume of data they've been looking for. There are also other early adopters that are looking into getting onto this platform or evaluating it. So we've got the food bank is using this initial work that we're doing with them to evaluate it as a potential backend for their pantry track system. So they want to take this. They have a very ambitious, formerly venture capital CTO, I believe, who wants to take pantry track nationwide to support Feeding America. And they're interested in seeing if this is something that can help them do that. We've got the Center for Urban and Regional Analysis and the National, that's out of Ohio State University. We've also got the National Renewable Energy Lab in Denver, Colorado. They're both interested in autonomous vehicle and electric vehicle renewable energy research, and they're interested to see, what happens if we can create federation between existing instances of this thing. Transparently query data back and forth between two different deployments so that you're not like, Denver and Columbus could exchange data without having to just copy it over the wire. We have a particular company, I am not able to name at this time, who's interested in using it as the brains for a smart building, like a large office complex or an apartment complex. They want to stream all of the data from their connected sensors into a central hub to be able to intelligently and quickly respond to issues. And there are other cities. One in particular is Portland and their Puddle project, the Portland Urban Data Lake. They want to look into this. They've had some of the stumbling blocks around some of the very issues that we ran into in our early research and problem solving around this space, and want to see if they can utilize some of our work to make their lives easier. But there are others that are either using the platform in quiet beta deployments or evaluating it as a component within a broader Smart Cities grant proposal, very similar to the one that Columbus originally won. But where are we going next, right? We have a plan. Nope, it was already there. Right, so we already provide embedded visualization of the data through the UI, but we want to expand on the tools that are available. We want to provide data analysts and researchers with the easiest way to interface with that data, the tools that they're most comfortable with. So we want to either embed that directly in the user interface as another option, or provide, say, plugins for exporting or interfacing directly into the tools that they're comfortable with. We want to build out the capability or the promise of that interoperability between clouds. We want to make that seamless. We want to explore multi-instance federation and, again, query data transparently between deployments. And then longer term, right, we want to be able to give users more choice based on the technology that they are most familiar and comfortable with. We want to abstract away some of those implementation details, like our message log. We want to swap out RabbitMQ for Kafka in certain situations. We want to provide different back-end storage systems for our applications to store that event state that I mentioned out of Brook. And we want to build out and include direct integration with some of those real-time processing frameworks or micro-batch processing frameworks like Apache Flink and Apache Airflow for accelerating users that aren't ready to dive in and write complicated Elixir programs. And that's all I've got. If you're interested in the code, it is entirely open source again. The primary repository is here. It is in the process of migrating to an umbrella project. Anything that is not in that repository is going to be in its own repository within that GitHub organization. All of our documentation is in this repository and its wiki. So the diagrams, question and answer about resources, how to get started, a glossary of all the ridiculous names of the things that we've built because we're a very meme-based team. And we are also in the process of evaluating a name change, right? We envision this could be useful to other stakeholders and parties than just cities, and we want to reflect that openness. So stay tuned, but anything that does happen will be communicated through that repository as well. We're also open to suggestions, so if you've got a strong one, please share it with us. We have a number of hex libraries that we've published that are not necessarily specific to this particular project. The ones that we think are really only useful to this project at this time are going to migrate into that umbrella, but the ones that aren't, you can find them under these GitHub repositories. We do a lot of this in our own time, actually, because we're pretty passionate about it. And then this one for the project itself, the official ones. And then there's me. I'm not one for pure social media, but you can find me under this username, again on Hex, GitHub, Elixir, Slack, and LinkedIn. And thank you very much. If you have any questions, I'd love to chat more.